Welcome to Day 7, Reciprocal Functions Part 2. Here are the materials that you will need for today. So first, I'd like you to remember that reciprocal functions have flipped values. We saw a little bit of this the other day, but let's review. Remember that you have reciprocal functions cosecant, secant, and cotangent. They are the reciprocal values of sine, cosine, and tangent. In other words, the cosecant of theta is equal to the reciprocal value of sine of theta. The secant of theta is equal to the reciprocal value of cosine of theta. And the cotangent of theta is equal to the reciprocal value of the tangent of theta. So let's investigate this in a more practical standpoint. Let's take a right triangle with a reference angle theta. I'm also going to say that the sides of this triangle are 3, 4, and 5, a nice Pythagorean triple. I can say that the sine of theta is equal to the opposite over hypotenuse, which is 4 over 5 in this case. If I look at the value of cosecant of theta, in other words the reciprocal of sine, I know that the value is hypotenuse over opposite, in other words 5 over 4. What you notice is that sine and cosecant at the same angle have flipped values. And this is the basis of today's lesson. So the question remains, how do we calculate reciprocal functions with a given angle measure? In other words, what happens when theta actually has a value? Well, we follow these 5 simple steps. First, we want to figure out what is the angle in degrees. If it's already in degrees, we leave it as is. If the measure of the angle is in radians, we need to convert it to degrees. And we do this by multiplying by our conversion factor 180 over pi. Second, we are going to figure out what quadrant is the terminating side of the angle in. This lets us know if the function is positive or negative. Third, we need to find the reference angle. We do this because we only know the exact value of certain functions at angles less than 90 degrees. To find the reference angle, you have to look at the angle between the x-axis and the terminating side of your given theta. Step 4 and Step 5 are the keys to this lesson. In Step 4, you need to know the reciprocal of the function you're given. Why do you have to know this, you say? Well, remember we do not know how to find exact values for cosecant, secant, and cotangent. However, we do know how to find exact values for cosine, sine, and tangent. So, if we know what the reciprocals of our functions are, we can rewrite the problems in terms that we know and find the exact values in terms of the functions, sine, cosine, and tangent. Well, how does this help us, you say? In Step 5, remember back to the first example that the cosecant and the sine had flipped values of each other when they had the same angle measure. Similar case here. You take the value of the trigonometric function that you know, and then to get the reciprocal value, or rather the value of the reciprocal function, all you have to do is flip the fraction, flip the value. Once you've done this, all you need to do is simplify if there are radicals in. So let's start with a couple of examples that have angle measures already given to us in degrees. Well, this takes care of Step 1 for us because remember, if we're given a function in degrees, we don't have to convert. We leave it alone. In example 1, we're given the function cosecant of 30 degrees. Remember back to the first example that the cosecant of 30, or the cosecant of any given angle, is equal to the reciprocal value of the sine of that angle. In this case, the reciprocal value of sine of 30. Because we don't know how to find an exact value for the cosecant of 30 degrees, we're going to use this technique instead to find the value of sine of 30 degrees, and then take the reciprocal of that in the end. So let's start by drawing our quadrants and drawing the measure of our angle, which is 30 degrees. Next, I'm going to look for the reference angle. Well, that's easy enough because we're in quadrant 1. 30 degrees is the measure of my reference angle. It's just the angle itself. Sine is positive in quadrant 1, so I can simply say I'm looking for the positive sine of 30. Well, if I remember back to my chart, and I should memorize this, sine of 30 is equal to 1/2. However, I'm not looking for the sine of 30. Remember, I'm looking for the value of the cosecant of 30 degrees. Well, sine and cosecant are reciprocal values, so I take the value of sine of 30 and I flip it. This means that the cosecant of 30 degrees will be equal to the reciprocal. In other words, 2/1, or just simply 2. In example 2, I have the secant of a given angle, in this case 60 degrees. Remember that the secant of any angle is equal to the reciprocal value of the cosecant of that angle. In this case, the reciprocal of cosine of 60. So I'm going to look at the cosine of 60. I draw my angle and label it. Next, I'm going to look for my reference angle. Once again, I'm in quadrant 1, so it's simple enough. It's 60. And I know that in quadrant 1, all functions are positive. So all I need to do is find the positive value of the cosine of 60, which from your chart you should know is radical 3/3. Next, I need to say, well, the ultimate goal of my problem is to solve for the secant of 60 degrees. So what do? I take the value of its reciprocal cosine, and I flip it. So the value of secant of 60 degrees will be equal to 3/radical 3. Now I need to simplify this by multiplying through by radical 3/3, and I end up with a value of radical 3 as my answer. In examples 3 and 4, we're going to use the exact same method, except here we're given angles that are in terms of radians. Well, remember step 1, if it's in radians, convert from radians to degrees. We do this by taking the value of the angle, 2π/3, and multiplying it by our conversion factor, 180/π. The pi's cancel out, and we're left with an equivalent value of an angle of 120 degrees. So we can rewrite example 3 as the secant of 120 degrees. Remember, we do not know how to find the exact value for the secant of an angle. We do, however, know how to find the exact value for its reciprocal function, cosine. So, what we're going to do is consider the cosine of our given angle, 120 degrees, find the exact value, and then flip it in order to get the value for secant of 120. So let's start with cosine of 120 degrees. Well, to get an exact value, we're going to need an acute angle. This means we're going to need to use the reference angle. I start by drawing my quadrants and then drawing my angle. It's 120 degrees. To find the reference angle, I note, well, I'm in quadrant 2, so this means I am going to take 180 degrees and subtract my original angle, 120. This gives me a reference angle of 60 degrees. Now I can rewrite the cosine of 120 using the same function, cosine, and the reference angle, 60 degrees. After that, all I have to consider is whether or not this function is positive or negative. So here again, I rewrite the cosine of the reference angle, 60 degrees. Now I need to consider, is it positive or negative? This is where I use my mnemonic, add sugar to coffee. Because I'm in quadrant 2, I know that only sine functions are positive. Because I'm using cosine, I know that the cosine is negative, so I look for the negative value of my function cosine of 60. From your chart, or using your memory, hint, hint, nudge, nudge, you should know cosine of 60 is equal to 1/2. So the negative value is obviously -1/2. Now, remember, I'm looking for the secant of 120 degrees, which is the reciprocal of the cosine of 120 degrees. So I take this, I flip it, and I get a value of -2/1, or just -2. In example 4, I follow the exact same method, except with a slight twist. I convert my angles from radians into degrees, and then rewrite my example as the cosecant squared of 135 degrees. Now, this squared is new, but don't be afraid. All this is saying is that we are looking for the square of the value of cosecant of 135. So we're going to look for the value of cosecant of 135 and then square it. Simple enough. Now, I have cosecant. which means I don't know how to find the values of cosecant, but I do know how to find the values of its reciprocal function sine. So I rewrite this problem as the sine of 135. I'm going to draw my angle, 135 degrees, in my quadrants. Next, I'm going to look for the reference angle. To do this, since I'm in quadrant 2, I take 180 degrees, subtract my original of 135, and I get a value of 45 degrees. Now I can say that sine of 135 is equal to the sine of my reference angle, 45. The question is, am I looking at a positive or a negative sign? I use my mnemonic add sugar to coffee, and in the second quadrant, sine is positive. So I'm only looking for the positive sine of 45, which, if you remember, is equal to radical 2 over 2. Remember, I'm only looking for cosecant of 135, so I'm going to take the flipped value of sine, which is equal to 2 over radical 2. Now don't panic, I realize there is a radical in the denominator, but when you square it, you get 4 over 2, which equals 2. And there's your answer. The next question we're going to consider is, what if you're given a function of theta equal to an exact value? What could theta equal that would give you that value if theta is between 0 and 360 degrees? Well, it turns out within the realm of that 360 degrees, that one circle, there are going to be exactly 2 values. To find these angles, we follow 3 simple steps. First, the sign of the exact value tells you in which quadrants the angles lie. For example, sine positive tells you that the angles lie in quadrants 1 and 2. Second, we find the reference angle by determining the acute angle that will make our given function equal to the exact value. Third, we will find the values of theta by adding or subtracting the value of the reference angle from 0, 180, or 360, depending on which quadrant we are in. In example 5, we're told that sine of theta is equal to a positive value. This means that our 2 thetas will lie in quadrant 1 and in quadrant 2, because this is where sine is positive. We label them theta in 1 and theta in 2. Next, we're going to find the reference angle. We do this by determining the acute angle that will make our function of theta equal to the exact value. In other words, what value of theta will make this statement true? Well, we know that the sine of 30 degrees is equal to 1/2. So we know that our reference angle here is equal to 30 degrees. Finally, we're going to use our reference angle to determine the exact value of theta 1 and theta 2. How do we do this? Well, we find the values of each theta in each quadrant by using the operations that we were given. In theta 1, it's just the given angle. For theta 2, we subtract 30 degrees from 180, and we get a value of 150 degrees. If you take the sign of either of these values in a calculator, you should get a value equal to 1/2. This is a good way to check your work. So let's practice this technique with examples 6 and 7. In example 6, you have the tangent of theta equal to the negative value radical 3. We're told that tangent is equal to a negative value, so we know that theta must be in 2 or 4, because in quadrants 1 and 3, tangent is positive. Next, we're looking for the reference angle. Remember, this is the acute value of theta that makes tangent equal to radical 3. And if you have memorized your charts, you should know that this value is equal to 60 degrees. We then label our reference angle 60 degrees. Third, we need to figure out what our 2 thetas are. Well, we have to label them theta in 2 and theta in 3. Notice that one is significantly larger than the other. To get theta of 2, what we're going to do is take 180 degrees, because we are in quadrant 2, and subtract the value of our reference angle, 60, to give us a value of theta equal to 120 degrees. So we say theta 2 is equal to 120 degrees. Theta in 4 will be equal to 360 minus 60 degrees. In other words, theta in 4 is equal to 300 degrees. So here are your answers. These are the two angles in which theta will make tangent equal to negative radical 3. In example 7, I'm given cosine of theta equal to a negative value. In other words, cosine is negative. If I draw my quadrants and label it with my mnemonic, add sugar to coffee, I can remember that cosine is positive in 4 and in 1, which means that the angle theta must lie in quadrant 2 and in quadrant 3, because these are the quadrants where the cosine function is negative. Next, I'm going to look for my reference angle. Remember that the reference angle is the acute angle that makes cosine equal to the exact value. In this case, the cosine of 30 degrees is equal to radical 3 over 2, which you should remember from your chart. If you can't remember, go back and memorize. Next, we label our theta in 2 and theta in 3 so we don't confuse what angles we're looking for. To get theta in 2, I simply follow the procedure for getting an angle in quadrant 2. I take 180 degrees, subtract the reference angle 30, and I come out with a value of theta in 2 equal to 150 degrees. Now for theta in 3, there are two different ways that you could go about solving this, and I will show you both of them. The first method is to take your value for your reference angle, 30 degrees, and subtract off that 180 degrees that is the left side of the x-axis. This will give you a value of negative 150 degrees. Well, remember, we're looking for a positive angle of theta between 0 and 360. So what I need to do is find that positive coterminal angle. In other words, add 360 to your negative value. You should come out to a new angle that stops at the same terminating side, and that is positive. In this case, 210 degrees. And what I say is that theta in 3 is equal to 210. The other way is to notice that theta in 3 lies 30 degrees past the 180 degree bar. So what I could say is 180 degrees plus the value of my reference angle, 30, will equal the value of my angle, which comes out to 210 degrees, the same value. In either case, theta in 3 is equal to 210 degrees. Here are the skills that you should be able to do. If you're having trouble with any one of them, please go back and watch the video or seek extra help. Until next time, this is Mr. Mackman signing off.